Thank you very much. Right, my name is Tom Card. I'm the 3D Survey Services Manager at LandScope Engineering. It is a survey company with plenty of years' experience. I'll come on to that in a bit. My objectives for today are basically to help understand how various technologies, various new technologies and existing technologies are used to map the riverbed scour around bridges and structures, and then also looking at how different data sets can be combined. So underwater, above water, laser, sonar data sets, plus a few other little bits and pieces can be combined to provide a big, rich data set from which various deliverables can be extracted. So I'll start off with some introductions, then we'll look at various current working practices, and then introducing these new techniques that we've been using. I'll talk also about how we control the data sets, how we combine the data sets, before looking at various enhanced deliverables that we've been putting together. So, LandScope Engineering, the company I work for, we provide various survey and geospatial engineering services. It is based on 26 years of domestic and international survey experience. We use a multidisciplinary approach. We have surveyors working out on the sort of streets of London, mapping buried utilities. We do building surveys. We do a wide variety of sort of laser scanning surveys, road mapping. And we've also done a bit of bathymetric work. That was based from our managing director's experience in the past. He likes to, every now and again, get on a little rib, potter out with a little dual frequency system, just getting some data on rivers and small lakes, things like that. Just likes to keep in it, really. And then we have basically our three primary bases, one in our head office in Shrewsbury, in Shropshire. We also have Plymouth and London offices as well. And so we've been laser scanning since 2007. We originally got the Leica scan station, which is a bit old and clunky now, but it still does the job. We have newer scanners since then as well. We were mobile mapping since 2011. We were the first in the UK, first company in the UK to get one of the Topcon IPS2 mobile mapping systems. And I'll touch on that as well. And then we've been using the Blueview, the BV5000. We did some trials last year, and we've recently invested in one. So we'll talk about that as well. So this is the project that I'll be referring to primarily throughout the talk. The scope of work were to scan the underwater elements of the bridge. This bridge is on the River Trent in Gainsborough. It is tidal. I don't know if any of you are familiar with the River Trent, but there is what we didn't realise at the time. They have something called the Aegea, or the Aegea, which is a little bit like the Severn Bore, where the tide floods in, and the basically floods in 2 hours and out again in 10. And on the various spring tides, you get a wave which comes up, which is just quite impressive. We're also we're looking at scanning the above water elements to provide a point cloud. So we're using laser scanners to produce a LiDAR point cloud. And essentially our client wanted to reduce or potentially remove the requirement to send divers down. So that was all working. So the current working practice, how could the data that the client was looking for be obtained? Well, for photography, if you wanted to photograph under bridge structures, you're looking at boat access, you're looking at potentially pontoons, scaffolding, maybe even rope access on larger structures, sending divers down to look into the water. And this is getting out, so you're getting photography, you're getting videos, you're getting diver reports, laser scanning can provide three-dimensional information, but also, say, bathymetry and multi-beam data as well. So that is, that's what they're currently getting. I mean, in this particular case, they weren't using anything, any bathymetry, some basic bathymetry, but no multi-beam. It's a very, very silty environment. And you'll see an example on the right there of the sort of diver report that they were getting, which wasn't telling them a huge amount of information. So they were looking to get more information than is being shown there. So let me show you the technologies that we used during this particular project, the BV5000. There it is, and that's you see our rib. The rib from where we deploy it. You can see here we've had an arm put on, which we can then lower and easily raise and lower the system into the water. And then we've got the Faro focus as well, which we use for alongside the scan station. So we'll use the scan station with its time of flight to get sort of 4 main scans of the bridge. You get a much better resolution on the sort of the dark and the wet surfaces that the Faro won't necessarily pick up, and then we use the Faro, which is much faster, to then fill in any gaps, perhaps over the top of the bridge, or if you can get right underneath one of the arches, put a scan under there. So, the Teledyne BV5000, the 3D mechanical scanning sonar. Just a quick just summary of what it's capable of. You can do a 360 degree by 30 degree scan in 6 minutes. So typically we're looking at around about 18 to 24 minutes to do a full sort of near dome scan. It usually takes maybe half an hour once of the system being in the water, once it's all been it's doing its post-processing well, maybe 5 minutes of that. So pretty quick really to get one of these positions here. It's compact, it's portable. It comes in a